So, like I said, guys, it's a continuation of what the notes we did. We've been doing for the last couple days. So it's just different questions. They're asking you different questions, but the rules are still the same. Everything's still the same. Okay. So if you haven't already, read number one. Take a look at number one. You can probably figure out what to do because you've seen that type of question before. Just now it's with implicit instead of explicit, which we've had in the past. So for the equation, they want us to find the for the implicit equation, they want us to find the equations of all tangent lines to the curve when x equals 1. We've seen that before, right? We've seen that before many times. Tangent lines. So if it's a tangent line, what do we got to do? Slope, which is how do we do that? Before we do that, we got to find the. There you go. So first thing we got to do is find the derivative. Okay, so we're going to find the derivative of the function. So the original is this. Okay, so we got to find the derivative of the first part here. The first part here, we're going to use product rule. So the product rule says the first times the derivative of the second. But I need a dy dx there because I found the derivative of y, right? Plus the derivative of the first, which is -1, times the second. Okay, so that's the derivative of the first part, plus the derivative of 5x, which is just 5. The derivative of 0 equals 1, but the derivative of 1 is just 0. Okay. All right. So now isolate dy dx. So everything that's not attached to a dy dx, I'm going to move to the other side of the equation. All right. So I'm going to subtract 5 here. And I'm going to subtract, actually add. I'm going to add y squared because that one doesn't have an x, or it doesn't have a dy dx. So those go away, those go away. I'm going to write this a little differently. Since this is multiplication here, I'm going to combine them. So -2xy dy dx equals -5 plus y squared. Divide by what I don't need. I don't need the -2xy on this side. I don't want that on this side. So I get dy dx equals -5 plus y squared over -2xy. Okay. That's where we stopped. We've been stopping there. But I didn't answer the question yet, right? I haven't answered the question yet. The question's asking me for equations of tangent lines. Okay? So in order to get equations of tangent lines, I need slopes. I need slope, right? Well, they say x equals 1. So what do you think I'm going to do with x equals 1 with my equation? With my derivative, derivative. Plug it in. Anywhere there's an x, plug it in. So I have dy over dx when x equals 1. Actually, I should probably write it like this. Okay. So I have -5 plus y squared over -2, plug in 1 times y. Okay. What do I do now? I ran into a problem. I need slopes, right? I need a slope. Well, in the past, right? In the past, in your past notes, we plugged in x and I got a number, right? The derivative is whatever, and then you plug in x and then you get a number, and that's the slope, right? How come I didn't get a number then? How come here I didn't get a number? Because you can look in your past or in your notes in the past. Let's see. So we plug in, we can't find one, but we plug in a number for x and we get a number out. We plug in x equals 1 and I get a number, and that's my slope. Is this a slope? Is that a rise over run? You guys? Yeah, the answer is that's not a rise over run. What's the rise? -5 plus y squared. How do I go up -5 plus y squared? How do I go over -2y, right? I can't do that. So we're going to have to do what you, Raj, said. We're going to have to find y as well. We can't just find x. Okay, so we know x is 1. How do I find y? Mhm. There you go. Plug in 1 to the original equation, because I'm going to need an x and a y, not just an x this time. In the past, x was fine because it was y equals something, 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 right? I plug in x, I got my answer. Here, it's not that way, right? So I'm going to have to plug in x up here. Oops. Okay, so up here at the original, anywhere I see an x, I'm going to plug in a 1. Okay, so I get -y squared plus 5 equals 1. Subtract 5 from both sides. I get -y squared equals -4. If I want to get y by itself, I got to divide by -1 first. I get y squared equals 4. What does y equal? You put that on a test, you'd only get half credit at most. Why? Yep, because you need the -2, right? Anytime we take a square root, anytime we're solving anything, anytime we're solving and we find a square root, you got to have a plus and a minus. You got to have one positive, one negative, because -2 times -2 makes 4. Okay. So we have 2 points. I have 1, 2, and I have 1, -2. I have 2 points at 1. When x is 1, it's got 2 points. Okay, these are a little different. So when x is 1, I have a point there and a point there. It's not a function, so it means it's not a function. Okay, you can see as you look, you can see kind of what we're dealing with here. These kind of things, right? These kind of non-function type things. That's what I told you guys. When we graph these, they're a little different than what we're used to graphing. They're not parabolas. They're not lines, right? They're curves, but they're non-function curves. So you see, like, for example, this has a dot here at 1 and it has a dot here at 1, right? 2 different dots when x equals 1. That's kind of the same thing we're dealing with here. Okay, that's why there's 2. All right, so now we got an x and a y. So I have an x and a y. I have an x and a y. So now, instead of just plugging in x, I'm going to plug in x and y. Okay. All right. So let me do it down here. First thing I'm going to do is plug in the derivative at 1, -2. That's the first thing I'm going to do. So my derivative equation was -5 plus y squared over -2xy. Okay. So anywhere I see an x, I'm going to plug in a 1. Anywhere I see a y, I'm going to plug in a -2. Okay. Now there's no more variables. So I'll get a number, which I wanted, which is the slope. So on top, I get -5 plus -2 squared. -5 plus -2 squared is -1, because -5 plus 4 is 1, -1. And on the bottom, I get negative times a negative makes a positive, so it's going to be 1/4. -1/4. That's my slope. Okay, so I'm going to put it into equation, just like I've done many, many times. The slope goes in the middle. X is 1, that goes over here. Y is -2, that goes over here. And you are done. Okay, now find the other one. If you haven't already, we got another point. We don't just have 1, -2. We had 2 points when x is 1. Find the other one. Okay, so if you finish, look up here. It's very similar to the one before. It's got a similar slope. They're just opposite. So one is going up 1/4, one is going down 1/4. Okay, and then the x and the y's are very similar. All right. So on these, you're going to have you could have multiple tangent lines, okay? Because again, the graphs look like this guy here. They look like this. So when I say find the tangent line when x is equal to 2, there's a tangent line here, right? But then, hey, there's also a tangent line here. Sometimes they're parallel, right? Sometimes they're not. Okay, those two look like they're pretty parallel. So they might have the same slope, they might not. Okay, so that's why. A lot of times what I see on tests and quizzes is students will find one. They'll find one and they'll stop. They're like, oh, that's it. Yeah, that was true before. Last chapter, that was true when we had functions. When we're dealing with functions, it's only one line, right? When x equals 1, there only has to be one y. Well, now there's multiple, okay? Because they're not functions. All right. Okay, so this one's similar. What do you have to do here? I see a lot of you getting started. Good. What do we do here? What are our steps here? What do we do first? Mhm. Find the derivative. Good. Once I do that, what do I do? Plug in what? Plug in both x and y. Yep. Plug in both x and y. And you're going to get a slope. That's asking just for the slope. You don't have to do any equations or anything like that. So it's easier than the last question. Okay, so do that if you haven't already. So in the past, what we've done is we've said, okay, when I get here, when I get to this guy here, isolate dy dx and then plug it in. You could do that. That works. But I did it a little differently here just to show you there's another way. Anytime you're plugging in numbers, you can isolate afterwards if you want. Okay. This only works if you're plugging in values. If you're plugging in values, like my last step is I have to isolate dy dx. So you can isolate dy dx up here, or you can do it later. It's up to you. Okay, I just did it this way because I haven't shown you this way, so I wanted to show you that you could do that as well. So like so I have to get dy dx on the same side, so I'm going to subtract 2 from both sides, and then I'm going to add 2 dy dx to both sides. Okay, so that goes away, so I have 2 dy dx plus 3 dy dx equals 2. Then I isolate dy dx, I factor it out, and I get 2 plus 3 equals 2. Divide by 2 plus 3, which is also 5, equals 2 over 5. Okay? That's another way of doing it. It works if you're plugging in numbers. Okay, so if you're just finding the derivative, you can't do that. You have to isolate dy dx up here at this step here. But if you're plugging in numbers, you can plug them in and then isolate later. Okay. All right. Okay, so do 9a. I want you to do 9a. 9a, the graph, it just shows you what this guy looks like. That's it. That's all we're going to do with the graph. The graph just shows you, gives you a picture of what this guy looks like. X cubed plus y cubed equals 6xy. Okay. So I want you to do letter A. Okay. You can probably factor the top. I think you can divide them both by 3 and get 2y minus x squared. And then the same on the bottom, 3y squared minus 2x. Because they both can be divided by 3. Again, on a multiple choice test, you might need to do that because the answer might not be this guy here, right? On a free response test, it won't be marked against you if you don't, because it's technically the right answer. It is the right answer. It just can be, factored out. Okay. All right. So found the derivative, isolate dy dx. Three x minus 3y squared. Did you do the same steps as me, or did you do something different somewhere?
For the first one, I just moved 6y over to the other side.
Let's see. So you moved, so you did 6y over here, subtracted 6y from both sides, and then you subtracted 3x, wait, no, then you subtracted 3y squared to over here? Okay. So guess on the next step, we should get the same answer. That's how you know your answer is right on the next step, because the next part wants us to find equations. So we should find an equation that's the same. Okay. Okay, so that's the derivative. Part B says find the equation of two things: tangent lines and something called a normal line. I don't think we've talked about normal lines before. Normal lines are perpendicular to tangent lines. Perpendicular. So perpendicular. So lines that are perpendicular. Let's see. Perpendicular lines look like this, right? What's true about perpendicular lines when they cross? Those are perpendicular lines. They make 90-degree angles everywhere, right? Right here, right here, right here, and right here, right? The corner of Dickinson and McKinley is perpendicular. Those are perpendicular lines. McKinley is one line. Dickinson's another line, right? Perpendicular lines. So perpendicular lines are, so a normal line is perpendicular to a tangent line. So does anyone know, so parallel lines, right? Parallel lines, lines that never cross. What's true about their slopes? They're the same. They're exactly the same, right? What's true about perpendicular lines? There you go. Very good. Perpendicular lines. Let's write that down. Perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocals. Okay, perpendicular lines have parallel lines have the same slope, but perpendicular lines have slopes that are opposite reciprocals. Okay, so what does opposite mean in math? What are opposite numbers? Yep. What's the opposite of +5? -5, right? What's the opposite of -1/10? What's the opposite of -1/10? +1/10. +1/10, right? It's just the same number, different sign. So opposite means we change signs. That's what opposite means, right? Reciprocals. What does reciprocal mean? Flip, right? So the opposite. So if I have a slope of 1/2, what's the opposite reciprocal of 1/2? -2, right? You flip it and you change the sign. What if I have -5? What's the opposite reciprocal of -5? +1/5. Good. Flip it, change the sign. That's what opposite reciprocals are, right? So that's how we know if two lines are parallel or perpendicular. Sorry, perpendicular. Okay. So these two guys here. So don't worry about this orange color right now. Just worry about the blue. Let's do the blue like it was a normal problem. Okay. And then when we get to the orange, we'll say, okay, what was it? What was the tangent line? Well, let's flip and change the sign and do the same exact thing. So it's not anything extra. You have the information. It's not any extra work. It really isn't. Okay. So let's look at the tangent line first. Let's do tangent line first. Tangent line first. Okay. So if I need a tangent line, I need a slope and I need a point, right? Well, I got a point right here, right? 4/3 and 8/3. 4/3 and 8/3. Let's see, 4/3. 4/3 is about 1 1/3. And 2/3 is just under. So right about there. That's the point they're talking about here. That's that point they're talking about. So you can already see what kind of slope it's going to have. What kind of slope is it going to have? What kind of slope is it going to have? Positive, yeah. Right? It's going to have something like that. Right? We don't know exactly what. That's what we're going to do the problem. But it's a way to check your answer. Right? If you get something that's negative, then you're like, I did something wrong. Okay? Okay, so we got to find the slope of that line. Okay, so we're going to use our derivative. Our derivative is right here. Okay, so our derivative was, let's see, x 4/3, 8/3. So everywhere I see an x, I'm going to plug in a 4/3. Everywhere I see a y, I'm going to plug in an 8/3. Okay, so really doesn't matter. I'll use the 6y. So 6 times 8/3 minus 4 times 4/3 squared. 3 times 8/3 minus 6 times 4/3. Okay. Wait, 4? Should be a 4, right? Should be a 3, yeah. Yep. I knew that 4 looked weird. Should be a 3. There we go. Okay. So 6 times 8/3. Well, 6 and 3 can both be divided by 3, so that makes a 3 and a 2. Same thing over here. I can't do that for 4/3 because it's 4/3 squared. So I can't cancel out the 3's because I have to square it first and then I can cancel it out. Okay, so let's see. We get what was 16 minus 3 times 16 over 9 because 4/3 squared is 16 over 9. And then we get 3 times 64 over 9 minus 8 because 2 times 4 over 1 is just 8. So now I can cancel out some of these guys. So this guy becomes 1, this guy becomes 3, this guy becomes 1, this guy becomes 3. So I have 16 minus 16 over 3, 64 over 3 minus 8. Okay. So 16 is 48/3 minus 16/3. And 8 is 24/3. So if I subtract the tops, I get 32/3 over 40/3. Again, I stopped doing calculus a long time ago. Okay, this problem, in fact, there is no calculus. It's just plugging in and reducing fractions and doing all that. Okay, Problem A was all calculus. That was all calculus. But problem B is not. It's just reducing these guys. So if I get, let's see here. So I get 32 over 3 divided by 40 over 3. Keep, change, flip. Keep, change, flip. I get 32 over 40, which reduces to 1/5. No, not 1/5. 8 4/5. You can divide them both by 8. You get 4/5. Okay. So now I have my slope. I have my y. I have my x. I have my slope. Done. That's the tangent line. Okay. Now I got to find the normal line. So what do I do to find the normal line? The equation of the normal line. Is it a lot of work to find the equation of the normal line? You guys did it earlier. What's the only thing that's going to change? The slope. That's the only thing that's going to change. Everything else is going to stay the same. Yeah, you guys were doing it earlier. I was giving you numbers and you're like, oh, that's negative 1/5. Whatever, whatever the numbers I was giving you earlier. So 8/3 is going to stay. 4/3 is going to stay. What is 4/5 going to be? Negative 5/4. Done. So it's not any extra work. It's just writing it down. That's all it is, right? There is no work for the normal if you've done the tangent because the only things that are different are they still go through the same point. They still go through the same point. One is tangent and one is parallel or perpendicular to that. So if the red is the tangent line, the blue is the normal. Right? The blue is the normal. Okay. All right. Okay, so something we haven't talked about yet, but hopefully it makes sense to you. Look at the next one. Wait. Let's do this one. Do number 11. Let's do number 11 first. Let's do number 11 first because that's the one you're going to see most often. Okay, so this is the graph here. Oval. It's an oval shape. It's not a function because there are multiple y's for every x. Okay, it doesn't pass the vertical line test. Okay, so which of the following, find the points at which this graph has a horizontal tangent line. So what does that mean when I say horizontal tangent line? Close. What do you mean by y equals 0? You're close. Exactly. So it looks horizontal means like this, right? There you go. That's what I was looking for. Is that what you mean? That's what I knew you. That's what you're thinking. Slope is 0. So we're looking, where is it going to have a slope of 0? So we already know the slope. We don't have to find the slope here. Slope is 0. Okay. We just have to figure out where. Well, you could kind of do that right now, right? Look at the graph. Where is it going to have a horizontal tangent line? You can kind of approximate it, right? Guesstimate it. Is it going to have one right here? No, it's going to have a negative, right? That's going to be a negative, right? Same thing over here. Well, about where will it have a horizontal tangent line? Where x is what? There's actually points there too. Where approximate it? Approximate it before we start, because it's a way of checking our work. Where would it have a horizontal tangent line? Mine's red, yours is not, but it's the same graph. Bro? So negative 2.9, let's see, negative. So negative 2.9 is like over here. Oh, y. Okay, so what about x? When x is 1.4. Yep, right at that dot. I would think, yeah, that's what I was thinking. That dot right there, somewhere around that dot right there. So somewhere around negative 1.4, I would say 1 is definitely 1, right? Because at that dot there, the tangent line is going to be pretty horizontal. Is there anywhere else we would have a horizontal tangent line? That's definitely 1. Where else would we have 1? When x is about 1.4 positive? Yep, right at that dot there. I would say somewhere around that dot, we're also going to have 1. So we should have 2. We know we should have 2 answers. We should have 2 dots. We should get 2 points, right? So slope is 0. Okay. Well, we're going to set our slope equal to 0. Well, we're going to set the derivative equal to 0. So the first thing we have to do, if you haven't already done it, find the derivative. Find the derivative. Okay, so now we got to isolate, oops, equals 0. Isolate. So I'm going to subtract everything that doesn't have a dy dx tag on it. So we get x dy dx plus 2y dy dx equals negative 2x minus y. Okay. Isolate. Factor out dy dx. Okay. They look pretty close. The negative 2x minus y and the x plus 2y, they look very close. Don't factor them out. They have to be exactly the same, right? And they're not. One's 2x, one's 2y. One's regular x, one's 2x. Okay, so they have to be exactly the same. Okay, even if I factor out a negative 1 here, I get 2x plus y, which is not the same. Okay, so be careful with canceling those out. Okay, so I got the derivative. Now, what am I going to do with that guy again? What did I say I was going to do with him? Set it equal to 0, right? So the derivative is a fraction. So what do we know about fractions and 0? So what do we know? I have a fraction. I know I have a fraction for a derivative, right? I have a fraction for a derivative. Um, what do we know about that and that? What do yeah, with a fraction. When is a fraction equal to 0? When the top is 0, right? If the bottom is 0, that doesn't make it 0. That makes it undefined, right? That's not what we're looking for here. We're looking for something that equals 0. So the bottom, I could care less about. Okay? Here, the bottom, I could care less about. My focus is on the top. Okay? So let's focus on the top. So that's where my focus is at. My focus is 100% on top. The bottom is, for this problem, it's not important to me because it has no, what did I say? It has no bearing on whether the thing is going to equal 0 or not. Okay, so find the points at which the graph has a horizontal tangent line. Okay, so negative 2x minus y equals 0. So what I could do is I could add y to both sides. Okay, so any point where that's true, you're going to have a horizontal tangent. So let me see how far they want you to go. Sometimes they just want you to give you the equation. Sometimes they want you to actually, sometimes they want you to go further. Let me double check my notes to see what we were doing on this one. Because sometimes they'll say, what's the relationship? Well, that's the relationship there. Let's see, where is this one? Okay, so let's see, find the points at which, so all points, so since they don't give us an x and a y, they don't say an x and a y there, what we're going to say is this relationship here. Anywhere that's true, anywhere I get an x and a y that equals that, that's going to be true. So if I plug in x and y and it's true, I'm going to get a horizontal tangent. Okay, I'm going to get a horizontal tangent. Okay, most of the times what they'll do is they'll give you an x coordinate and they'll say, for this x coordinate, give me a y that'll give you a horizontal tangent. So the main thing to realize about this problem, or to remember about this problem, is that when we're finding horizontal tangents, the top is all I care about. We skip this one, but this one's a vertical. What do we know about vertical tangent lines? What's their slope? It's not 0. What is it? Not 1. What's the slope of a vertical line? It's all rise, right? All rise. What's the run? There's no run. It's 0. So if you have 0 on the bottom, what is it? Undefined. So we would set the bottom. We're going to do this one tomorrow, but we'll set the bottom equal to 0 there. The bottom equal to 0 there. Okay. All right. Okay. All right. We'll finish these tomorrow.